So let's start with trigonometry. First off, trigonometry is one of those things that's an interesting animal because I'm hoping after today you're like, yeah, that's not so bad. But if you talk to, maybe not your parents, they might not be old enough, but I know like my parents and a lot of that generation, they had to take trigonometry was one of the math classes they took, like it went algebra 2, then trigonometry. I don't necessarily know why they don't teach a whole class of it anymore, but this is one of those things where, in my opinion, again, this is just me, who is pretty decent at math, but I thought this basic part of trigonometry wasn't too bad, but then once you get a little bit deeper, it gets pretty hard pretty quickly. So the good news for you guys, we're not going to go into that part that gets pretty hard pretty quickly. Again, I'm not saying this is easy by any means, but it's definitely doable, I should say. Last thing I'll say before we get started is, in my opinion, the part that is quote-unquote easy on this is the math. The hard part is making sure you're staying consistent. Make sure you know when you're using what trig function. Make sure you know what the ratio is going to look like. But it's a lot of memorization stuff, in my opinion. For the solving, it's usually one step, and then you put it in your calculator. So the first thing we have to do, and it's not a bad idea, if you have your own calculator, you probably don't have to do this very often, or once you do it once, you don't have to do it at all. But if you're going to use my calculators, you're going to want to check this before you take a test. You need to make sure that your calculator is in degree mode and not radian mode. So if you have one of the calculators I have in the back, the Casios, if you look at the very, very top of your screen, there's where it says the word math somewhere, and then there's maybe another letter, and right to the, just barely to the right of center, there should be a D. That means you're in degree mode. If you are in radian mode, it should say R. If that's the case, let me know and I can help you switch it. Or again, if it's my calculators, if you just go to where it says setup, so you hit the shift button and then setup, and then you just click the number 3, that option puts the degree. If you don't have it in degree, if you don't have it in degree mode and you're using a different calculator, again, I can come figure out how to put it. And if you're not sure, if you just wait, once we get to where we're using our calculator, actually, I could just put in. So if you want to make sure you're in degree mode, put your calculator right now. There's a button that says SIN, is pronounced sine. Put in the sine of 25. 3. That should give you 0.4226. If that doesn't give you that, then you're in radian mode. That maybe is a problem. Oh, I had to shift. All right, so if it becomes a problem later in this lesson, if you're calculator and giving the wrong answer and you're not sure why, definitely let me know and we can check that. You want to make sure you're in degree mode. Just really quickly, the difference between degree and radians is just another way to measure the distance or the measurement of an arc or a circle. So for instance, you know how a distance in like miles, you can either go miles or kilometers. They're both measuring the same thing. They're just different ways to say it. It's the same thing. You're using degree or radians. 2 pi radians. So it's just another way of that stuff. Okay, so let's get into some of this important vocab stuff. About the opposite side, I should probably include the word side there. If I talk about the opposite, is the side across from the triangle or across the triangle from whatever angle we're working with. So I'm going to go ahead while we talk about this and fill in here. So this angle is what we're talking about, and we'll talk about what that symbol is in a second. So the opposite side is the one that's across the triangle, so it doesn't touch that angle at all. The opposite side is the one that the only side that doesn't touch that angle. The adjacent side is the side that is right next to your angle, but it's not the hypotenuse. I should have put the hypotenuse first. So this one, the adjacent is A. It's the one that it's right next to the angle. It's right beside it. It touches the angle, but it's not the hypotenuse. And the last one, the hypotenuse is the longest leg. So for our example, that'd be C. This in there mainly because I went through all high school was calling this the wrong letter. It is theta with a TH. I thought it was beta with a B. I should have known better because it's not a beta, but I just didn't, I guess. So that theta, it's a circle with a line through it, and it is a variable that we use a lot of times when we're talking about degree measurements. So a lot of times rather than using X or Y, for whatever reason, when there's a degree that you're trying to look for, they usually say that it's a theta. Not all the time, but this is the opposite adjacent hypotenuse from that angle theta. If it's the same exact thing, but now we're talking about angle X, it's all the same stuff, you're just obviously talking about different sides. So now we're talking about angle X right here. The opposite side would be A, because that's across the triangle. Your adjacent side would be B, because that's right next to it. And your hypotenuse is always the same. That's one that doesn't change. The hypotenuse is always the longest side. Now, if you ever aren't sure which side the longest side is, always remember that it's the opposite side of the 90-degree angle. So I guess I forgot to read this. It was up here on your notes. These are all what we're doing today is trigonometry with right triangles. So all of our angles are all of our triangles today with right triangles. If you ever can't tell what your hypotenuse is, it's always the opposite of that 90-degree angle. Now, some students ask, and some of you guys probably thought of it, but what about the 90-degree angle, and I asked for the opposite adjacent hypotenuse for that one? We won't do that because that gets really confusing because now the opposite side is the hypotenuse and there's two adjacent sides. So that we won't ever deal with it's up a 90-degree angle. For reasons for that, but I'm not going to get into those today. Any questions on those? So the next thing we'll talk about, and if you talk to anybody that has done any trigonometry, this is probably the thing they remember, I hope. The phrase SOHCAHTOA. Now, I should have put this over here, but the three trig functions is what they're called. We'll deal with is the sine, cosine, and tangent. Abbreviate those to SIN, sine, cosine, COS, and tangent, TAN. So sine, cosine, tangent, and again, just kind of like we did with the log of like 4. Remember how I told you that's just a number, that's just some decimal, and you can treat it just like any other number? Same thing with sine, cosine, tangent. So we'll take the sine, cosine, tangent of different angles. We always take the angle. And that's just a normal number. It's going to be a weird decimal or something like that, but you can treat it like a normal number. We'll get to that in a second. But before we get into cosine tangent, we're going to talk about SOHCAHTOA, because when we do this, we're going to make a ratio of the different sides of the triangle. So whatever the side of theta, that means we're starting with that angle, and then we're going to use the ratio of the different sides. That's why we know which one to use, and then what the ratio is going to be. So SOHCAHTOA, what the cliffhanger, we'll get to that in a second. What it stands for is the first letter is always the function you're going to use. So means we're using sine. We're the opposite of the hypotenuse. Or the other way, if we have the opposite of the hypotenuse, we're using sine. Cosine hypotenuse, and tangent goes with the opposite and the adjacent. So the first thing we're going to do is quite literally, we're just going to write down what these trig ratios are. So what is theta? Now you won't see SOHCAHTOA down at all. It's always going to be sine, cosine, tangent. I just been trying to ease you into this. The SO of that angle represents this angle theta is equal to the opposite over the hypotenuse. So my opposite is done here, my hypotenuse is here, so it's 4/5. Please do so. Reduce it, that's fine. Not an A, that can be confusing. Stands for adjacent over hypotenuse. Your numerator always comes first, so that means cosine of the angle is the adjacent over the hypotenuse, so 3/5. And TOA stands for the tangent, means we're using the opposite over the adjacent, so 4/3. That's the first step of this, just finding out those ratios. Again, I'm not going to give you SOHCAHTOA on the test. I'm not going to give that to you on a formula sheet or anything, because that's one of the big things is that you can remember that. And again, I don't know who invented SOHCAHTOA, but often that a lot of people, they forget that it's sine. They call it SO, and cosine, they just solve CA. Or trigonometry, they just call it SOHCAHTOA. That's fine. I don't care as long as you know what those stand for and what those mean. So the next one, we're going a little depth. Now I'm just saying cosine tangent. So this is what you're giving normally on a test. So if I ask for the trig function, you'll be giving sine, cosine, and tangent, and then you just have to realize sine means it's the opposite of the hypotenuse. If it helps you to label these right away, you can. So that is the opposite of our hypotenuse is 8 over 17. Cosine is the adjacent, ca, over the hypotenuse, 15 over 17. And tangent is TOA, is O over A, is 8 over 15. Now, I mentioned this up here, and if you memorize SOHCAHTOA, you don't actually need this at all. I didn't realize this worked out until like probably a couple years ago. But the opposite side, the O, is always in the numerator. The hypotenuse is always in the denominator. The only one that switches numerator and denominator is the adjacent side. Work, but if you just remember SOHCAHTOA, you'll be fine. So go ahead and do these next ones on your own. Just make sure you're remembering what angle you're using. So if I were you, I would do the sine of x. We're using this angle. And so I would label opposite, adjacent, hypotenuse. But remember, that's only for the ones with the x. So I'll do the x's first. And then when you do the theta ones, now you're going to have to switch because now the opposite is the 6 and the adjacent is the 8. So just make sure you're being careful which angle you're using because that's going to determine which one's the opposite, which one's the adjacent. All right, so those are the answers I have. If getting those answers, or, I mean, obviously, I guess I should start with, this is one of those things that for me, I already, when I was making the answer sheet for this worksheet, I messed some of these up. And it's not because I'm not good at them, because I've done a lot of trigonometry in my life. It's just that they are very easy to confuse. It's one of those things that you're not using a lot of brain power to remember what you're doing with it. You're just writing down something real quick. So a lot of times you go too quickly and you miss some of these. So just be careful. And it is hard to make sure you keep everything straight, especially when you're jumping around, sometimes using one angle and sometimes using the other angle. Make sure you're asking, because if you don't understand this, it's going to make the rest of the lesson very difficult. If you do understand it, you're sitting pretty good. We're good? So those are just the ratios. Now we're going to talk about the main reason we're using, or we can use what we have today, is finding missing lengths of this. Now there's another thing to do, and if we had one more lesson trigonometry to teach, there's other ways where if you know two of the sides, you can do trigonometry to find what the angle is. We're going to do the opposite, where if we know one of the sides, angles, we can find one of the other sides. So, if you look at number 7, this is a very typical problem we'll have, where they give you the angle, and like I said, all of what we do today, they'll give you the angle. And they give you one other side, and they want you to find a second side to that. Technically, we could do this to find all 3 sides, and I'm not going to give you any of those. Maybe we get a different question. So I broke down the steps to solving this, and honestly, as usual, I try to make it as small steps as I can to make sure you really can follow along if you need to. I personally think I would maybe take step 2 and 3 and put those into one step. But again, the big one is 4. 4 is the one that takes some work. The rest of it isn't too bad. So, first step, label your month size. Now, the reason I put that in quotes is because that's not an actual math definition. That's what I made up. And what I mean by that is, if you look at number 7, the sides that they have is they tell you 20, and that's the hypotenuse. They want to find x, and that is the adjacent to that angle, 64. The opposite side over here, we don't know what that is, and we don't ask to find what that is. We don't care about that side at all. We can ignore that side, and we don't have to worry about it. Because again, we don't know what it is, and they're not asking us to find out what it is. The hypotenuse, we know what that is, so we're going to use that. The adjacent, we don't know what it is, but they want us to find that one, so we're going to use that. The opposite side, again, they're not asking any information, we don't know anything, so we're not going to use that. So then figure out which trig function you're going to be using for this. Well, if there's an A and an H, and we're talking about so, ka, toa, then which one of those has an A and an H? Well, not so, that's an OH. Not toa is OA. It's got to be ka, so ka, toa is the one with the A. And what that tells you is the C stands for, using cosine, then it's all step 2 and 3 go together. I set it up as I go with this, as I find the ratio. But when you set it up, it's always in the same order. You start with a trig function, and then you put your angle there. That little, it looks like a less than symbol, kind of. That's the symbol for an angle. You guys will get really used to that next year with Mr. Thorburn. So the cosine of the angle, 64, is equal to, and this is where we do our trig ratios that we just did. It's the adjacent over the hypotenuse, so it's x over 20. Now, that's steps 0, 1, 2, and 3. Step 4, is everyone okay? Everyone on board with why I got cosine, why I set up the ratio the way I did? And make sure, and again, this is one of those things, I've done this long enough, but I feel like it's obvious, but it's very much not. Make sure, again, the angle always goes with your trig function. I've had people mess that up all the time, and it's because I literally just don't even remember to say it, because for me, it's obvious. I've done it a bunch. So, if you can get the rest of it is solving, and in my opinion, the solving part, I mean, it takes a little bit of time, but I think the part is this part. Knowing, and I think I said step 4 is the hard part. I guess I should have said step 4 is the most work, but I think the hard part in this is making sure you choose the right trig function, make sure you have the right ratio. Because when you're solving this, just like any other fraction, you want to get this x by itself, and multiply both sides by 20. Calculator, all you have to do is type out 20 multiplied by the cosine of 60, 64. Calculator 20 times cosine of 64. That gives me 8.77. I'm going to round to 2 decimal places. That's your answer. That's it. What we just found is that length x is 8.77 inches a mile. They don't tell us what measurement they're using. But that's all there is to it with solving. So again, I'm not standing up here saying that it's super easy by any means. I have a lot of people that it's hard to get their mind wrapped around this, but in my opinion, and I could be wrong, the hardest part is making sure you know that it's cosine and making sure that it's x over 20 and not 20 over x. Once you have that, I personally think the solving is not too bad, and you're using a calculator. I know this is ridiculous, but bear with me. We're going to skip the next couple, and I'll come back to them in a second, and I will tell you why in a little bit. It's totally a mess up that I made, but it's okay. I'm compensating. So number 10, we're dealing with this angle. So since that's the angle we're dealing with, this is the opposite, and this is the adjacent. SOHCAHTOA, which one is dealing with the opposite adjacent? Using tangent. Your angle, that's O your angle. The opposite over the adjacent. And last step, now we're solving that. Well, to solve for this, again, since we're dividing by 14, we multiply both sides by 14. And like I said, the tangent of 54 is just a decimal. You could actually type in the tangent of 54 in your calculator. So you could replace that with 1.376. That's what that is. That's what tangent of 54 is. But the punchline is you treat it just like any other number. So we multiply by 14. We just multiply 14 by the tangent of 54. So it's 14 multiplied by the 1.37 whatever. But again, it's way better to put it in your calculator. 14 times the tangent of 54. That way you don't miss little things from rounding. So that length should be 19.27. Again, if you're not getting that, if you're typing 14 times the tangent of 54 in your calculator and you're getting a different number, you're probably in radian mode, in which case I can come help you and we can fix that problem. Yes, question.
So how do you know which one adjacent one and the opposite one?
The adjacent one and the opposite one? So the adjacent one is always the one that's right next to your angle. It touches your angle, so it's just directly to the left or right. The opposite is the one that you have to cross the whole triangle to get to. The opposite one does not touch your angle. And this isn't as common anymore, but it used to be adjacent. If you're wondering why they call it the opposite, hypotenuse, and adjacent, adjacent used to be a much more common vocab word in just every normal day like language. Like if you were looking for the hardware store and they're like, oh, it's just adjacent to the grocery store. People used to use that terminology. I imagine they got picked on a lot, so they stopped. At least that's why I did. Not the story that. Okay, so this is where it gets, I wouldn't say harder, but it gets a little different. You just have to be on your toes. I'm going to go back to number 8. And before I do number 8, I'm actually going to talk about this one. So if I gave you this problem, I said, you solve that. Now here's the thing. A lot of people miss this because they either multiply or divide both sides by 30, and that's not right. So I'm going to show you the long way to do it, and I'm going to give you a shortcut. The long way to do this problem is I don't know what to do when x is in the denominator, and so the only thing I know how to do is I'm going to multiply both sides by x. So that cancels the x, and now I have 10 times x is equal to 30. Now I know it seems like that was counterproductive. It seems like we didn't get any closer to finding x. We didn't really take any steps forward. Absolutely right. A problem we can solve. I know how to solve 10x is equal to both sides by 10. And that cancels. 30 divided by 10 is 3. So I wanted to make sure I showed you that. That's why we do this, and that's how we do this. We do it in 2 steps. But here's the shortcut. And this works anytime you have a problem that looks like this, where you have some number is equal to a fraction. The shortcut to this, now that I've showed you that, is if you ever notice your denominator is one with a variable, you can just take that 10 and take that denominator and just switch their places. And that's pretty much what we have over here. Again, it's just both those steps into one denominator. You can just switch those places. So you know that if you look at the next one, number 8, the A we're given, so that's the one we're dealing with. So we have the opposite across from the triangle and then the hypotenuse. Which one uses the O and the H? It's so. So that means we're using sine of that angle, 40 degrees, is equal to the opposite, 17 over the hypotenuse is x. Some students, when they get to this point and they thought it was really easy, and now they think it's really hard. I maybe would argue that this looks a little bit strange, but once you get the hang of it, this is maybe easier. Because all you have to do to solve this is take the sine of 40, take the x, and switch the sides. So your answer to this one is x is equal to 17 over the sine of 40. And again, you can just put that in your calculator. If you put it in as a fraction, a weird fraction answer, just change it to a decimal. But literally, this is 17 divided by the sine of 40 is 26.45. Sorry, I ran out of room there. No, I think next one, I think number 9 does, and I don't think number 11 does. So, okay, so the difference, that's a good question. So it's not that I'm doing sine cosine tangent at all. It literally all depends on if you're, when you find your ratio like we did earlier, if that variable is the variable in the denominator. So if we would have done, not to like, don't write this down obviously to confuse everybody, but we could have the same exact problem we had over here, except for it's changed. If I change 8.7, if I change that to 8.7 to the x, and we redid this one, now we use cosine of 64. 8.7, the adjacent over the hypotenuse is x, and so we'd have to switch those. So it doesn't depend on whether it's cosine or tangent at all. It all depends on if your denominator is the one that you're looking for. If your hypotenuse is the variable, it definitely is going to be one like this. The adjacent, again, that sometimes in the denominator, sometimes not. Does that help answer your question at all? Okay. So number 9, we're using tangent. We have the opposite and the adjacent. COA means we're using tangent. Tangent of 34 is equal to the opposite is on top, the adjacent is on bottom. So again, you do everything as usual. Here ratio, if the denominator is a variable, that's when we switch. In the x, we switch those. So end up getting x is equal to 11 divided by the tangent of 34. And again, that's just a calculator problem. Whoops. Is 16.3. I'll be honest, round correctly. A lot of people just put 16.3. It's kind of a long story. I professionally decided to handle that. And the last one, obviously, I was copying and pasting this from a worksheet that I found online, so I apologize that it worked out this way. I tried to avoid it, but all the last ones are all tangent. Opposite, adjacent. But with this one, the tangent of 25 is equal to x over 10. So now the x is back up in the numerator because that was the opposite side. And so now we solve the other ones. Multiply both sides by 10. 10 times the tangent of 25 is 4.66. And again, keep in mind, every time we find one of these, that's what that missing side would be. So this side would be 10.67. This side would be 19.27. This side is 16.31. And then inches, miles, kilometers, meters. I obviously know that my notes are a mess right now because I can't write small enough with the stylus. Any questions so far? Now, again, like I said, I would never say this is easy. Once you get the hang of it, once it clicks, I don't think it's too bad. But I totally understand where it's a lot to keep track of. Trying to figure out sine, cosine, tangent, try to figure out opposite adjacents, try to figure out what goes in the numerator, goes in the denominator. There is a lot going on. But all that going on, or most of it, isn't solving stuff. It's a lot of it is just whether you're going to be able to memorize and get enough practice that you know where to put everything. So go ahead and do those other 3 in a row, or those last 3. If you have any questions, please let me know. All right, so the last one we get to, again, when you get to geometry, you'll do a lot of these with story problems. In my opinion, as far as story problems go, I think these are pretty decent. Because really, all I'm going to do is they're write this whole scenario, but in that scenario, they're describing a triangle, and you're just going to make sure you draw that picture. So the most people that hate these problems, that hate story problems and miss these, most of those people, the reason is because they tried to do it without drawing a picture. So my son threw a sticky hand and got stuck to the wall. If you know my son, that's not a true story, but very plausible. Got stuck to the wall. It was so high that I had to use my 15-foot ladder to get to it. I put the top of the ladder right where the sticky hand is. The bottom of the ladder is on the floor. My ladder made a 75-degree angle with the floor. How high up the wall is the sticky hand? So here's the wall. My sticky hand right here. Here's the floor. Over with a ladder because I need to get the sticky hand down. The top of the ladder is right where that sticky hand is. They say this is 75 degrees. And then it says we're trying to find how high is that sticky hand. So how far from the ground to where it's stuck on the wall, how high is that? But some students read this and they're like, well, they don't give us enough information. Well, they actually do because remember, they tell you that ladder is 51. So this ladder, whatever angle that's at, the ladder is a 15-foot ladder. You can't say, oh, well, what if it's a 60-degree angle, it's shorter. That doesn't, they should buy a new ladder if that's the case. Certainly don't want them. So once you have that, now all of a sudden the story problem becomes a problem that we just got done doing. So this is the angle we're working with. So we have the opposite and the adjacent, or sorry, the opposite of the hypotenuse. That was close. And that, and again, maybe it's just me, in my opinion, that's the hardest part, is making sure you don't make little mistakes like that. So sine is 75 degrees. Again, the angle always goes there. We have the opposite over the adjacent, sorry, the hypotenuse. I wrote it right, said it wrong. And that x all by itself by multiplying both sides by 15. 15. So the Greeks pronounce 15. Yeah, I made that up. 14.49. Technically it's feet, but I'm not going to worry about that. But now, before we go on, before we're done with this, I just want to make sure I mention it. Some people do these story problems, and they're like, oh, that's not that bad. And they think that every story problem was done this exact same way. And it is, where you're always going to set up a triangle, but you're not always going to use sine. Like, there are times that I give you this where I say, the sticky hint is 14.5 feet off the ground. How long is the ladder that I used? Or how far away is the ladder from the wall, the base of the ladder from the wall? We aren't going to get into it today at all, but sometimes they say, what angle does the ladder make with the ground? So there are problems that we'll get to, we're not going to get to this year. In geometry, there are problems where you'll have to find that angle. And if you enjoy this stuff, you're going to like that. It's pretty good stuff. Yes.
I'm getting to take the one that says can A. I'm not sure if that's supposed to be close or can.
Me neither.
It's close. Thank you.